Hey y'all, it's me, Miss B, and today we are graphing reciprocal functions. Reciprocal functions are functions that model inverse variation and are of the form f of x equals a over x, where x is not equal to 0. And we did talk about can't be equal to 0 because then we have an undefined graph. So here's what a reciprocal function looks like when you graph it. It is increasing, going from it's decreasing as x values are increasing. So y is decreasing as x is increasing, and same here. It's just reflected over that x equals y. Okay, so then I'm asking a question, will the graph touch the x-axis? What do you think? The answer is no, but it will get very close. So if we think about that problem that we had from a few days ago where we had x times y equals 24, now it always has to equal that, but no matter what I divide by, I will always have a number. Even if that number is really, really small, it just makes y very, very big. So we'll get really, really close, but we will never get to 0 because 0 times anything is 0. So we can't actually have 0 as an answer. Okay, and so that creates something called an asymptote. So asymptotes are lines that the graph approaches, however, it never touches as x gets really small or as y gets very large. So y equals a over x will have the x and y axis as the asymptotes. Okay, we have this thing called a vertical asymptote, and it'll look like this. And it's the line x equals h. That looks like an n, but it should be an h. And the graph is not going to touch that. Or we have a horizontal asymptote, which would look like so. It's just a horizontal line. And usually we show those as dotted lines, but for now it's fine. And it's going to be the line y equals, actually, we'll leave this as n and make this m. That's fine. Well, we'll make it h and k again. H and k. Okay, so then let's go ahead and look at this function here just to kind of put everything in one place and understand a little better. So we have this thing called a vertical asymptote, and the line is going to be x is equal to h. Then we have a horizontal asymptote, and the line is equal to k. So here's our h, and then here is our k, looking at that graph. Then the domain is going to be all real numbers not equal to h. So here is not equal to h. There's h. And then we have our horizontal, or all real numbers not equal to k, and there's k. Okay, so that kind of clarifies where everything goes. So let's go ahead and jump into this first example here. So here I've got my asymptotes, and this is just a header. And we want to find the vertical asymptote. And the vertical asymptote is going to be x is equal to h. Now here is my h value right here. That 6, because it's going to be minus always. So x is equal to 6. Okay, another way of thinking about it is you set that denominator, x minus 6 equal to 0, and solve. So then it turns into x equals 6. So let's graph that line. 1, 2, 3, 4, 5, 6. It is vertical, so we will make it vertical. I like to use a highlighter. Some people like to draw a dotted line. That's fine. I wouldn't make it a solid line, though, because then that gets confusing with your graph. All right, then for my horizontal asymptote, it's going to be 2. It's written right there. So this is going to be y is equal to k, or y is equal to 2. So I'll draw that line. 2. You can make it a dotted line if you want to, if you don't have a highlighter, but do not make it a solid line. And so then we have that. So we identified and sketched the asymptote, and then now what we have to do is sketch the curves. Now, this is negative, so it's not going to be this way. It's actually going to be reflected and go this way. So it just looks like that. And we'll get more into graphing a little bit more later. But basically, these lines are going to get really close to 0 without touching. So they'll come close to 0, and then they'll start increasing and get really close to 0 there, or to our asymptote, but never touch the asymptote. All right, our domain, so our x values are going to be everything except x is not equal to 6. And then our range is going to be everything except y is not equal to 2. All right.